All right, so I'd like to invite Jitu Kumar from Oak Ridge National Laboratory to speak to the Discovery Cluster here about the Earth System Grid Federation, and in particular, the motivation for this presentation, for me asking him to come on, is to look at the way that they cite data, in particular the model output that's used for the climate assessment work by the IPCC and in the peer-reviewed literature. So without further ado, Jitu, just take it away.
Well, thanks, Jonathan, for the invitation. So just to kind of introduce myself, I'm Jitu Kumar. I'm a senior staff scientist here at within Environmental Sciences Division here at Oak Ridge National Laboratory. And I'm part of Earth System Grid Federation project. And of course, people who are aware of Earth System Grid Federation, it's just an international, organization where a lot of countries and a lot of institutions are involved. And within Department of Energy funds some of the work that we do. And the work is being done in a partnership between three national labs, so Oak Ridge, Argonne, and Lawrence Livermore. Oak Ridge National Lab is the lead within for the DOE project here in US, and we've been doing a lot of work recently. And today, what I'll talk to you about is this, what we are calling the next generation Earth System Grid Federation. ESGF has existed for a long time, has supported multiple IPCC assessment cycles, and the next one, which is CMIP 7, that the data is expected starting to sort of roll in sometime late this year to early next year. There's a significant amount of technology refresh that we've been doing. And we, as in not really just me or any of the institutions that are part of our project, but a lot of work that I'm going to talk about is really work of a lot of institutions across a lot of different countries that has all sort of come together to make many of these things happen. So what I wanted to do is I wasn't really sure exactly what my exact audience is going to be. So some of the repetitions, I'll kind of give you a quick sort of high-level overview of what ESGF is, and then kind of dive into what are the sort of key major changes that we are working on for this next generation ESGF architecture. And then since the focus of the ESAFE cluster, there are a couple of things that I wanted to particularly sort of pick out of that larger sort of architecture and talk about was the work that we've been doing on data indexed and search and the technologies that we are bringing in. And some of those are a change from what ESGF has been. And if you have used ESGF before, there are things that are just going to be very, very different now, at least on the back end technology, and which is a good discussion to have in this particular group. I'll talk about the search and discovery, and in addition to web UI that we've always had, there's some new work that we've been doing and some new tools that we have released that provides a CLI interface and some Python library, so to allow one to search and discover and download data programmatically. And then, and this is based on some of the interactions I had with Jonathan, I'll also touch upon some of the work that we've been doing for data citations and DOI and things like that. I'm happy to be interrupted anytime during my presentation. Happy to take questions in between. So if and when you have something, don't hesitate to interrupt me. Otherwise, I'll keep going. So Earth System Grid Federation is an international consortium of globally distributed peer-to-peer network of data servers. And the one nice thing about ESGF is that every node within the ESGF network follows sort of similar set of protocols and interfaces, really deploys exactly the same software stack everywhere. So even if the data nodes are hosted in different places and indexes are hosted in different, the users should get sort of same experience. No matter which node you go to, you should be able to download and search in all the same data sets in the back end. It primarily distributes a system model outputs, and these outputs are primarily are the simulations that are conducted under the umbrella of CMIP, or so WCRP, which is the World Climate Change Research Program. These simulations and all these simulations that are being done that feeds into IPCC assessment reports. In addition to those model outputs, there are associated data sets that are input to those models. So there are a lot of data sets that are included within as a part of the input for MIPS collection. There are observational data sets that are part of the ops for MIP collection. And there are a number of new reanalysis products, reanalysis project. There are we have recently added several sets of downscaled model data sets as well within ESGF. And I'm not going to go in all in detail of that, but there's a wide range of data sets that ESGF is curating, storing, and distributing. All of the ESGF data sets are openly and freely available. So there is no sign-up requirements. There is no, anyone is able to come and search the data and download the data sets that ESGF distributes. And just to kind of give you what the current data holdings look like, just kind of going back a couple of generations of CMIP, CMIP 5 was about an order of a little over a petabyte, but the data volumes are growing, as we all know. CMIP 6 was a little over 16 petabytes, and with some replications, in different places, we have our data holdings are at the order of a little over 27 petabyte. CMIP 7, which is the next round of CMIP that is expected. As of now, our expectation is that the total data volume will be in excess of 100 petabytes. And this is a screenshot that I just took of what our current data holding looks like. And you can see a quick in terms of numbers, in terms of total number of data sets, and that are available within ESGF, and overall total volume of data sets that we have within ESGF. And this is a full federation view of all the data sets that we are storing and distributing. So this is the latest architecture diagram for what we are calling the next generation version of ESGF. And this is everything. This is everything from the points where users are coming and interacting with the systems, as well as data providers and model developers that are creating these data sets. So how everything is sort of coming together. So at the top, and I hope you can see my cursor, but at the top is the pieces of sort of data discovery and how we are going to programmatically access these data sets. And the middle is where we are maintaining our data indexes and our catalogs. And there are some new changes, and I'll come back to some of those as to what these different catalogs are, how we are working through the publication process. So a modeling center that's generating the data is pushing the data and ingesting the data, and how that entire process is kind of going through. And then at the bottom is really where how these different services are hosted at a range of nodes across the federation. And just to highlight that there are sort of two tiers of data nodes that we think within ESGF. Starting from the left end is a what we think is a full functional, fully featured tier 1 data nodes, which is providing data storage and distribution capabilities, and in addition, will offer some server-side computing capabilities. And these are some of the new work, and I'll touch upon that later on in my presentation. as well as some new capabilities to provide user computing services, as in have some computational capabilities where a user can come and don't really have to download any data, but rather just a Jupyter Hub type environment where you can come, log in, load up the data, which is right there residing next to the system, and work with it. And some nodes are able to sort of offer some of those services. Some are not, but it's not really a core capability that is required of ESGF. It is a capability that that many of the data nodes are starting to sort of offer. But otherwise, I think the tier one data node is a node that is hosting the data sets and providing distributing those data sets. The definition of tier two data nodes come in play when there are situations where a modeling center may be able to host the data sets that they are producing, but they're not replicating data sets elsewhere. So all of the ESGF data sets are getting replicated. So you often will have a data node very close to you where you can get a faster download. So if, for example, if you're in the United States, downloading from an ORML node will be a lot faster than downloading from a European node. And but this is all volunteered services that the nodes sort of come together, and everyone is able to sort of offer services that that meet their own programmatic needs, the resources that they are able to bring to the larger federation. Today, I'll talk about a couple of things here that are highlighted in blue. The pieces of data discovery. And of course, data discovery really builds upon how we catalog and save our data sets. So I'll talk a little bit about that. And then a few elements of data DOI that is part of our publication process. So if you have used ESGF data before from any of the ESGF data node, and have looked into it. So in past ESGF versions, including actually the version that most of the data nodes that you can actually go and look at today, with the exception of ORML data node, the ESGF has used Apache Solr as the technology base where we store our data set, and that's really how we enable the search of that metadata set and this data discovery. Now, over the years, Apache Solr has worked well, but the way Apache Solr was deployed and designed, there were a lot of index nodes that were operating across the globe, and they were all independently operated and maintained by the individual data nodes. And they were a federated set of index nodes, so they were actually talking to each other and trying to sort of stay in sync. But over time, it has become harder and harder to actually maintain those nodes. And as of now, there are 7 Solr nodes that are operating. And I added this +2 because 2 of the nodes that we operated within DOE labs, we have already replaced those with a new technology, and they are still up and running, but they are not being used. So and they are going to go down pretty soon here. They are replicated, and at end of the year, and when the next generation architecture kicks in, all of the Solr is going to be go away, and we won't no longer be using Solr. So again, I think I already mentioned that these nodes were federated, and the search were being done in a distributed fashion. So even though these nodes are now all across the globe, the UI was always doing a distributed search across these nodes. But we had, again, a number of limitations. They were difficult to maintain and resource consuming, especially because now multiple institutions have to deploy and manage these. There were a number of security vulnerabilities that has been difficult to keep up with. So there was a lot of need to start to look at the alternative. And then one of the major issues that we've had, and especially from the user point of view, was that these nodes went offline at times, and many a times some of those are unavoidable. And depending on which nodes were available online, the search experience varied. So you may go search something today and you've got 100 data set, and then you come back tomorrow and it may be 110 or it may be a 90 if a node went online or offline. And we've been some of those have been known issues, and we've been trying to sort of address that with some of the work that's kind of ongoing right now. So the next version of ESGF is going to be using spatiotemporal asset catalog, so stack. And I'm sure most people on this call don't really need introduction. Are already aware of the stack technology, which is being developed by a fairly large open source community. Started out with observation community, has been deployed at a lot of different agencies and across the world. And one of the benefit that we saw by adopting this technology was that we can actually readily use a lot of tools and a suite of softwares that are already available that support stack. And then it really enables integration with other Earth observations data sets as well. Many of the data nodes across the world that are going to be deploying ESGF node actually are providing services for other data sets as well. And it enables some new features even for the end user that we think are going to be very useful. We are going to have two cloud-based indexes, which are going to be mirrored. And the benefit that we think these new indices will provide over the past technology with Solar is that every single time you should get exactly the same answer, because really it's just a one copy. It's just, they are mirrored, and everything is in one place. Unlike previously when we used to have these data shards scattered across different Solar nodes, and we were trying to do a distributed search. So as I said, Solar nodes will be retired, and that technology will no longer be supported. We are working on everything that I'm talking about is still work in progress. Nothing is in production. Everything is in testing phase. So everything I say, you have to take that with that grain of salt, that it is work in progress. But stack, there's an active stat catalog that you can actually go and look at if you go to CETA, which is the organization doing a lot of that heavy lifting on ESGF in UK. They have a CMIP6 catalog that they're using, and we have a version that we're working on, but it is not online yet. And I'm happy to drop additional links, and these slides can be shared, of course. So there should be. So this is just a quick closer look at what these index will look like. And we are working with this whole notion of a Western index and an Eastern index. And we're really talking about two sides of Atlantic here. So there is the current plan is that we will be within DOE labs, we'll be running a copy of this Western index, and Eastern index is going to be run by CETA. There is slight difference in underlying, the way the technology is being deployed, but we are trying to do the same thing slightly different ways. So on our side within DOE labs, we are using Globus. So Globus is a partner on our project. So we are using Globus Search and Index Services, which is using Elasticsearch under the hood. And then we are providing a Stack API on top of it. So for all practical purposes, anyone who comes to use our services will have access to both standard Globus APIs, but then also the full suite of Stack APIs to interact with the data set. On the Eastern Index, on the CETA side, they already have a version of Stack Catalog in place, which is again using Elasticsearch. But we have developed a scheme which is using a federation-wise event stream based on Kafka queues that is designed to keep everything in sync. And we are currently going through a whole lot of testing to test out our system. And I'm not going to touch upon any of the event stream that we are working on, but I'm happy to answer a question if you have a specific one later on. So once we have a new index in terms of Globus index or these stack sort of catalogs, we are our primary web UI is Metagrid, which several of the nodes have deployed, which allows a faceted search interface and a faceted search based on the control vocabulary that is defined for all of the CMIP projects. And it's a Java React based framework, which has already been deployed at several nodes. So all the DOE nodes, Oak Ridge, Livermore, and Argonne have a version of this deployed and available. And then several other ESGF node across the world have already deployed it, or towards the end of this year, we expect that almost all the nodes will adopt this web UI. And underlying changes in the index technology and the search technology that we have enabled is all integrated within this web UI. So now it offers things like, you can have a shopping cart, so you can download the data without any authentication, but you have an option to authenticate. And if you are authenticated, you can save your searches, you can save your shopping cart, you can share your search, so it will give you a URL, and that you can actually pass it on, or the JSON for the string for the save for searches. So anyone who you can share it with can exactly duplicate the same search anywhere. We have integrated Globus transfers. So a lot of ESGF users, when they're coming in, are trying to download a large amount of data set. And oftentimes they don't want to download their data set locally on their own system, but rather on their supercomputer of choice, where they're going to be doing a lot of these analysis. So you can, of course, download it directly with HTTPS. There is a link or you can use wget. But when you are trying to do a large data transfer, you now have an option to take that, do the search, put everything in your cart, and say, okay, now transfer this to a Globus node on my a NASA support supercomputer of my choice, or a DOE supercomputer, or anything else, and you just authenticate with the standards of your Globus ID, and it will enable all the transfers directly to the machine that you're trying to work in. And we think that some of these new capabilities will allow the process of downloading and searching data sets and getting to the analysis platforms that you're working with a little bit easier. The user experience, again, we think that some of the new faceted search improvements that we have made will make the user experience a little bit better, and then the Globus integration to move the data to your computational platform in a faster way. The other part of the data discovery tools that we've been working on is what we are calling intake ESGF, which is leveraging a lot of work that has gone in on the Python, just the intake libraries. And what the goal behind developing intake ESGF was to allow for a programmatic method of searching and downloading. So you don't have to ever come into a web UI. Every data set that we have with an ESGF you should be able to write a Python code to query that data based on your search criteria, and find out what the data is available and download it. So it provides an API access to all of the data sets that within ESGF data holdings. It is backward compatible, because when we started it about a year ago, we still didn't have a version of stack catalogs available to us. So the good thing is that it is able to support both the Solar nodes and older technology, as well as stack-based catalogs, and it will it has capabilities to do OpenDAP for data streaming. Several of the ESGF nodes are going to have support for virtual ZAR, which is a ZAR type formats that are more cloud and ready data format of using technology like virtual jar and Kerchunk. So you should be able to use the tools that we're building to stream data, to do the subsetting and so on and so forth, that some of these technology like ZAR enables within within intake ESGF, and you can do it within your Python based your codes, do the search and download easily. It integrates several other things. So it integrate the errata service, which means any known issues that we have, that we know of, any data corrections and so on that we have made is included in an errata service that ESGF maintains, and by intake ESGF by default will already look at the known issues and handle that for you. One other important thing that intake ESGF does is the data nodes are scattered across the globe, and intake ESGF tracks the speed that you are able to communicate with a particular data node, and keeps a log in the background. And depending on where you are, it will automatically identify the fastest place that it thinks that you can get the data. Of course, you can override it, but it will automatically identify the fastest place that you actually can get the data, and it will pick a server for you, so you really don't have to do anything. You never have to know where the servers are, where they're running, and all that. You just write your code, and it will find the data and download it for you. And it supports all possible ways of downloading the standard HTTP TPS. It can do GLOBUS transfers, can do stream it, and you can, if the data is available locally and you point it to a local cache, it will just skip over and just load the local file. So you can have a fully repeatable workflow designed based on top of intake ESGF, and which basically, if the data is available, you just load it and go with it. If data is not available, it will just go in the background and download it, search and download all of those data sets for you. And I've included some links. Intake ESGF is it's already released, and it's a very good working version already out there. So yeah, give it a try, and if you have any questions, feel free to leave a comment on our GitHub page, and we'll be happy to help you with that. And then the last piece that I wanted to talk about is that there are additional services that we are trying to sort of offer within the context of ESGF. So we are working all the way from a user-friendly UI and starting to offer a number of server-side computing services. And I really don't have a whole lot of time to go into details of it. And but what really that means is that we hope to be able to offer new capabilities to not really just give you the data that you really are interested in, but there are times when you want a higher level derived quantities, or you want a subset in space and time. And with the derived quantities, I mean, like, if you, for example, are interested in decadal mean or an annual mean of air temperature, you really don't have to download all the monthly data and then calculate the mean. We are trying to create a catalog of widely used functions, or widely used operations that we think the users really want to do, and we are trying to talk to a lot of the user community to understand what a list of those functions should be, and then give you an option to say, take this data, perform this calculation, and give me the final derived data products and not really the original data products. So there's a lot of work that's kind of ongoing on that side, which we are calling a server-side computing services. And then the user computing service, where essentially we give you a platform to come where all the software is there, the data is there, and you can just do your work there. Again, those capabilities are limited depending on what resources we have available, and at times there may be the local policy that a particular ESGF data node may choose to enforce for use of those services. And then I wanted to sort of switch gear and see if any question before I talk about some of the work on DOI. And So I only have like 2 more slides here. If not, I can continue on. Yeah, Jonathan.
Yeah, well, it might be a distraction mostly, but was curious on Globus and are they a private company or how are they partners? Are they being funded like DOE from federal sources?
Yeah. So the Globus started out of Argonne National Laboratory. They are based out of University of Chicago. So they are partners through our uh, Argonne lab partners.
Mhm.
And so the way it's working, so yes, they are a commercial company, but all the services that they provide is available for free as a
Okay.
part of our partnership. So, and this
And
is including all the services that are available for not only just the data users, but internally for the people who are working within within and developing these nodes. All the services extend to all the data nodes for free.
yeah, I had heard about some of their service offerings, but from your
Hmm.
presentation, it sounds like they
Hmm.
have a much larger
Yeah.
ecosystem, if for lack of a better word.
Yes. Yes. And then a lot of things that we're doing is not really a part of the standard Globus portfolio. This is they're leveraging some of their capabilities, and they are doing some work just for our project.
Oh, great.
Hmm.
Thank you.
Yeah, because they have the right expertise. We were able to get up and going easily with the work that they have already done, and they had available to the capabilities that they had available to us. But that uh, the license agreements and all of that is taken care of as a part of DOE funded project.
Great. Thank you.
Mhm. And this is from this slide, I'm switching gears a little bit and talking about DOI and data citations. And so the DOIs have been issued, you know, even for the past version of ESGF, except some of those happened a little late, and we were not really quite in sync right we were not really ready at the right time. So oftentimes the data were published and then the DOIs were issued. This time around, we are getting our services ready, so the DOIs are assigned before the data publications are happened, right before when the data preparation has happened. So all the DOIs can be baked inside their CDF files. So we can do this thing a little bit more systematically. And then this time around, DOI inside a file is going to be a requirement as a part of a standard attribute that we expect every data file to have. That was not the case last time around because oftentimes the data was created and the DOIs were minted later on. So just a sort of quick overview of how everything is going to work out across uh, the entire sort of process, which is, oftentimes is complicated because there are a lot of parties involved in this case. So there is so the starting point essentially, which will happen months before the data is actually published, is the DOI pre-registration. So we have already, and I'm on my next slide, I have a little bit of kind of overview of what the granularity that we are using for assigning these DOIs. But we are essentially, are building a pre-registration sort of web UI where modeling centers can come and say, yep, I want ESGF to issue me a DOI for my model and under this scenario and for these runs, and they will get a DOI and that they can take and then include it within their data preparation, put it on their files, and then we are tracking internally, and we are using DOE OSTI's interface and their capability that DOE OSTI provides, which is to register data through data cite. So all the data registration goes through data cite. And we are essentially giving them we reserve a DOI, hand it to them, and we are tracking who was assigned what DOI, and the data centers, modeling centers will actually go and put the data into the DOI. And when they are ready for data publication, our publication tool will go and check each of the file and validate it and make sure that it is a right match. We did not do any error. There was no error. There is no mix and match. It will validate it, and then it will update the record with the data side to make all the DOIs active. So really, that's really kind of how we are going to sort of work through it, and then it will automatically populate all our catalogs. So if you go to a stack catalog, the DOIs will be available, so you can actually hit our API, and still will be able to find all the data citations and things like that. We're using these DOIs this time because now we will have it early on. We think we will have a better tracking of the metrics of the data used as they are getting cited within these publications. There is a lot of effort on being able to track all the data sets and that are going to be part of assessment reports, and down to a particular figure and what exactly were contributed, what data sets kind of went in and creating the particular figure. So there's a lot of work going on, and we're getting ready to have our services in place. And this is still work in progress. This is not really finalized. We are starting to issue a handful of DOIs right now for some of the projects that are ready, but most of the simulations really are not even started yet, or are at very, very early stages. So we still have some wiggle room to sort out some of the details of our implementation at this stage. But in terms of granularity, I think this is what we think as currently our thought is that this is what it will look like. We think that we will be able to encode some identifiers within the DOI itself to make it a little bit easily identifiable and readable. It allows us to take a large number of DOIs that one is working on, right, and then take that and then sort it through. So within using the controlled vocabulary that ESGF is using, I think we will be able to encode MIP era, which version, like we are talking about CMIP 7, we're CMIP 6, CMIP 5, and so on and so forth. What was the institution that produced this data set? Source ID really is just the model name. So what model produced this data, and then what experiment it was done under. So it can be SSP 245, it can be SSP 585, it can be 1% CO2 scenarios, so a range of them, and then a unique identifier. So it start to help us group these data sets together, provide us a way of better tracking it. And then, as I mentioned, we are trying to get this thing, all services ready in place, have that in place long before the data sets are ready for publication. So we can issue these DOIs before the data sets are created, so they can all be included within the NetCDF. Again, we'll do a full sort of QC to make sure that the DOIs are paired with the data sets that it belongs to. And then couple of things that I think already mentioned. We're using DOE OSTI's E-Link service to register these DOIs. Our current plan is to build the service to auto-generate these landing pages, and these landing pages we're trying to sort of follow all the guidelines that DataSite provides, and other information that we already know about these modelings, model simulations, to include it within the landing pages that we are going to sort of create. And I believe this is my last slide, so I'm happy to pause here and take any questions. I went high level in some places, but that was kind of intentional. So I don't, without knowing my my audience, I didn't want to go too deep or too shallow in on most of these items. So happy to engage in more Q&A here.
Yeah, definitely a good overview, because where I came in, I was really focused here on one of these landing pages, and the way that it was able to identify which publications the model, the simulation, or whatever the experiment was being cited from. So that either the IPCC report, in some cases peer-reviewed literature, And that's to me like that's a discovery opportunity when people find they read a report, say IPCC report, they want to find other articles that are associated with that. Well, sometimes you need to go to like the Web of Science or some other indexer to find those relationships because there's no direct relationship between these different uses of the same data. But
Yeah.
that's like a really important paradigm for data set discovery that I think we're just trying to find these examples and highlight them
Yeah.
and really mature this use case for data set discovery because it's underutilized.
Yes, absolutely. Yeah, and I think within different data search and discovery interfaces we're building tools that allows you to group the models, the scenarios, all that in such a way that you can identify what the relationships are, how they all go together. And then with these DOIs, we hope that the way we are trying to sort of capture these, that we can identify some sort of relationships um, as to what the inputs were, what the different scenarios were, and what's feeding into what.
Yeah, and from an outsider's perspective, I'm not a modeler. I don't work in this domain, so it was a bit of like fish out of water trying to understand what I was looking at, honestly. And like there might be a, in that interface you showed, the new one that has the data ordering. I was just looking on that before coming on this call, and just under CMIC 6, you can find there's hundreds of data sets that to my eyes look identical. It's like, okay, well there's a lot going on here that's like not,
Yes.
it's
Yeah.
like technically it's all there, but it's not being presented, and it's really because I'm not the intended audience for this. But I
Yeah.
just was really impressed by all the thought that's really gone into this system, and I appreciate the overview because that at least gives me some foundation to understand
Yeah.
how this fits in to that broader
Yeah.
broader workflow.
I completely understand, there are probably variable names that, I doesn't really mean much to me either. I think they are a faceted search. And so within from NetCDF, for the search purposes, we harvest just both the variable name as well as long name, but there are times long names are exactly the same for multiple different variables.
Mm.
So it can be confusing. So to aid with that, and things that again didn't really talk about here. So there is we're doing a lot of sort of concerted effort to better document what the control vocabularies are, what these variable names really mean. And so hopefully the next round of CMIP 7 will have a better description that will be linked in these pages for one to go and sort of understand what these 100 of these different variables are. I mean, they are those they exist somewhere. Just they are oftentimes not really easily searchable. And I think we are trying to sort of bring those things together and consolidate a lot of our documentation. And then one thing that just sort of worth noting, and this is really very much experimental work, is that within our group here at ORNL, we have a couple of folks that are looking at developing our large language model, which is trying to go through uh, all the documentation, all the control vocabulary that really we have available to us. We are integrating some of these new Python-based search tools that we are developing. And the idea was that, okay, can we leverage these large language models to be able to build uh, a search platform that will take a question from a user in a natural language to be able to say, I don't really know what the TAS is, but give me a surface to air temperature, and find me the data set for these. And I think we think we have pretty good success with some of our early implementation. And really, we are trying to sort of get to a point where you don't have to really know the terminology that is being used by the modelers, right? Exactly what you just said a minute ago. I think we want to sort of reduce those barriers, but offer a range of different ways of interacting with our data sets and our catalogs, and be able to search these. So if you prefer, if you know all your variable names and you know your model names exactly, the faceted search will be perfect for you. And if you know everything and more, and you want to write your Python code that you never have to leave your terminal and just continue to work, then I think we think that we will be able to offer a API, a Python-based API that will enable that. And for more of a generic use, we think that's this some of our current efforts on developing a large language model based a tool that will allow you to search just with some natural language, um, will, uh, will be very helpful for, especially as there is more and more interest and public interest in some of these data sets, and it's not really what I would call the scientific climate community that was using and interacting with these data sets. So I think with the suite of tools that we are kind of building towards, we hope that we can address several of these aspects of search and discovery.
Cool. Yeah. I mean, it's such a great example to look at, and in some ways, you're developing this at a scale that many other institutions wouldn't need to do because they don't have terabytes of data. But potentially these are some solutions we could look forward to implementing as a community in the future for across domains, that where we do have that problem of scale and distributed data.
Yeah, absolutely.
So I was looking at Colin to see if he had any questions.
I guess, yeah, a little bit of a fish out of water here myself as well. But the pre-registration of the DOI and how that enables a tighter coupling to the data entity that's being published is a neat idea that I hadn't really thought of before. And presumably this is due to the self-describing nature of NetCDF. You can embed this sort of information there and expect to be able to access that, right? Is
That is
my
correct.
understanding? Okay.
Yeah. Yeah. So the DOIs will be inside the data file, and then within the catalog entry within this as the asset associated with this and stack catalog, it will also be it will also be there.
Yeah,
But
that's really interesting.
But
How tight?
yeah, and because it's important that DOIs are assigned ahead of time in this case, because the files have to be written and they have to know what to enter for the model. And it takes a while to there's a lot of data processing steps that oftentimes the modeling centers have to go through in order to meet the required sort of format. And so we are really kind of trying to um, allow them to say, okay, come and what model simulations you're going to be running. So go to the system, register it, and we'll record it. So we'll never let you do it twice, right? And in fact, we have allowing option that someone may choose to not really use our DOIs because they may have something institutional or whatever, right? Some other sources that they want using. But we certainly want to be able to let them have this option to be able to say, okay, that you should come and get a DOI ahead of time, and then put that inside your NetCDF file. So all the files are trackable, because it can be a model can have 100 files, and it's important to track those.
Got it. Yeah.
So when you're talking about a NetCDF file, and those are to prepare that data set to be used in analysis, to be cited, so to speak. But for
yes.
that analysis, you might have hundreds of NetCDF files that get cited. Is that right?
So within ESGF, all the millions of files that we have, we expect that we'll have a DOI for, each one of them will have a DOI.
Sure.
Yes. So
But
that's
then
what. Mhm.
what you're preparing them, so to speak, to be used in a product somewhere.
That's
That the endpoint that's not determined yet. You're
yeah, that
not
is
doing.
correct.
It's not for a specific purpose, but it's
That is,
now
yeah.
this NetCDF
So
file can be reused anywhere.
that's correct. So later on, if someone downloads thousands of these files for a bunch of different models and different variables, they do some scientific analysis, and their outputs when when they do they can create that, use the DOI to say, okay, in order to replicate all of their analysis, you may have to go and find these data sets associated with this 10 of these DOIs, and then you should be able to go back to ESGF and say all the data sets that were part of this, give that to me, and so you can redo this, and you know exactly where the sources of these data sets came from.
Well, it's really interesting example, and I look forward to looking at all this information in greater detail and learning more. So I just want to thank Jitu for coming to present this to us. I'm going to stop the recording, and